Hey everybody, Jason here. Just want to let everybody know that we are completely fine. It is Thursday morning here, and Hurricane Michael did not affect us whatsoever. Please excuse my appearance. I feel and look like complete total garbage. It seems like whenever you start to accept that you're getting sick, that's whenever you really start to get sick. This started out about I don't know, 4 or 5 days ago, where I was just kind of dizzy and I'd stand up and lose my balance, and I was in denial for a little while, but then once I started to accept that hey, I got something going on, well, then I started getting a sore ear. And anyways, I'm gonna do this anyway. Today I'm working on an iPhone 6 that was sent here for no backlight. I have in fact confirmed that this is no backlight, and I'm going to show you how it is that I fixed it. This one is not the filter, and I'm going to show you why it is that I know that it's not the filter. The iPhone 6 backlight, it only fails in 3 different ways. I think there's only 3. One of them is due to technician damage, which that is the blown filter, FL2024. Another one is a shorted cap on backlight output. That's just happens from dropping. I've had it happen, which seems like for no reason at all. And then the third one that I've ran into, I think I've only seen it once, is whenever the PCB actually shorts internally. Like, these things have a way of getting a short on the backlight output line, the backlight anode line, and not have anything else wrong. I've only seen it once. It's a really weird situation, and to fix that you wind up having to rebuild a whole new backlight output circuit without using the traces in the board. But let's not go into that. I'm going to show you which case it is that I have here. Here in front of me, I have an iPhone 6, and this iPhone 6 has a non-working backlight. Now, when I run into a no backlight phone, the very first thing that I check is under a microscope on the iPhone 6. If it is the filter, you will see right away that FL2024 is blown. This little guy right here, it'll typically be black on top, and then sometimes it's actually gone because of a screwdriver getting crammed up under the connector. Now this one, FL2024 looks fine, so I'm not inclined to think that we have an issue with a filter. So I'm going to turn the multimeter on the screen here so that you can see what it is that I'm seeing. Let's connect that to the computer so that you actually get a good reading. And the first thing that I do is I check for a short on this pin right here. And that is our backlight anode. And as you can see, this pin is reading 0.000 ohms to ground. That is a solid connection to ground. I'm going to switch you over to the schematics here and show you what it is that helps me determine. If we zoom in here and we look at that pin, we'll see that that pin is PPLCM. Tell you what, can we just, maybe I should move, let's move me over. There we go, that'll be better. Should probably brighten me up too. What the heck's going on with that? Anyways, let's just keep moving on here. So this pin is PPLCM backlight anode con, and that pin should not give us a solid short to ground the way that it does. Let's see. So switching back over to the schematic. And zooming in on the backlight driver here, we have PPLCM backlight anode con. I feel like I've probably explained this a half a dozen times, but I'm going to go ahead and do it again. So on this side of the circuit, you have VCC main coming into the backlight system, and that's what powers the chip. That's what sends power over to the backlight. Well, some power goes over to the backlight, but ultimately the chip develops a boosted output and gives us an elevated voltage over here. Nonetheless, if any of the capacitors on this side of the circuit get shorted, then that leaves L1503 and D1501 to sink all of the current that's going to create from VCC main into ground. So what that causes is for one or the other or both of this coil and this diode to get blown open. And in that situation, once they're blown all the way open, you can wind up with a phone that will boot without a backlight. Now, I do run into many of these that are shorted in such a way to where they don't actually boot. That's because for whatever reason, the coil and the diode are like in God mode, and they are sinking the current, and it's just they're not blown open, so it just sits there and gets hot and doesn't boot. So let's move on with this repair. So we have decided that we definitely have a short on this side, because if it was the filter, that would be a blown, you know, if it was on the outside of the filter, you'd wind up with a blown filter. So looking back here at the backlight circuit, if we actually look at FL2024, here's the backlight filter, okay? Sometimes it's really annoying when the board view and the schematic switch back and forth when you don't want them to. So if we had a short out here on this side of the filter, it would cause us to have a blown filter. But in this case, our short is actually on the inside of that filter, which leads us to this part of the circuit right here. So let's go ahead. I'm going to go ahead and I'm going to remove the board from this thing. Let's see, I've already got me a screw pad going here. So let's see how fast we can get the board out of this thing. And see if I can make it through this repair. Really dizzy. You talk about hard to keep up, guys, whenever you're already faced with a heavy workload anyways, and then you start to get a little bit sick, man, it really sucks. And this type of sickness where you're kind of dizzy, it seems to have really taken the confidence out of me. Like things that would not normally bother me emotionally have bothered me, and it's sort of a little bit maddening because I feel like having a lack of confidence and feeling overwhelmed and having a high stress level can enable you to get sick or lower your defenses down, and you start getting sick. And then on the other hand, getting sick and not feeling just right upstairs can raise your stress level and lower your confidence. So it's sort of like a catch-22 situation where, is this even recording? Yeah, we're recording. So one causes the other and amplifies the other, and it sort of goes back and forth, and it's just it has not been a good week, man. But here I am. I'm on YouTube anyways. I'm gonna publish a repair here that I've done, probably a couple hundred times, and hopefully because I've done it a couple hundred times it'll work out. I may record one here this afternoon that I'm pretty well certain will not work out, but for the sake of showing the customer what sort of a mess that they actually sent in, I think I might go ahead and do a video on it. Not to embarrass anybody, although sometimes I feel like that is necessary to stop some of the garbage that gets flooded in here, but just to genuinely show this guy, hey look, your buddy royally screwed your phone up. Okay guys, here's the board. The board is out of the phone. The first step for this repair is going to be to remove the shield from the board, because this is going to be under the shield. So I'm going to go ahead and turn my hot air on. I'm set at 380 degrees C, and I'm airflow 40 out of 100. And I'm going to go ahead and remove the shield, and then I'm going to remove the sticker from the back, just because a lot of times doing this, I have to use a lot of alcohol, and it just makes the sticker on the back, like it washes all the black stuff off and it looks like crap. Not that the sticker really matters, but it matters to me because I'm an idiot. Alright, so we're just about up to temperature here. My air is at 330 C. Should probably let the air heat up before I start on this. There we go. Shield falls off, nice and pretty. Now the next thing I'm going to do, I'm going to go ahead and pop this into a board holder. This board holder drives me nuts. I'm going to have to buy me a board holder now that I'm used to using one. What I run into is that these things come out. You put them under pressure and they go fling, fling, fling. They fling out. I mean, it's not the end of the world. You just have to be careful with it. And for the longest time, I didn't use a board holder. Now that I use a board holder, I'm sort of spoiled on it. Okay, so I can't get this in there too tight, or it will fling up in the air like a jack-in-the-box or a slinky. All right. Now we have this board under the microscope. I'm going to go ahead now. I'm going to turn the multimeter off the screen because we do not need the multimeter for soldering. And looky here, we have got a diode that is just blown to Kingdom Come. It's got a big hole in the middle of it. That is a big blown up backlight diode. Now, to give you a little bit of a rundown, as to what it is that we're going to be doing today, we have got backlight output highlighted here. And the caps that are in question are either this little one here, which it never is, or it's one of these three here, which it always is. So for this repair, what I'm going to be doing, just because L1503 and D1501 took one hell of a short here, we know D1501's blown. What I'm going, you know, it's really tempting to just replace D1501, not mess with the driver, and figure out which cap it is. But on the iPhone 6, I almost always wind up just replacing the whole lot of it. So to save myself much headaches, we're going to be replacing all three backlight output caps, 1, 2, 3. We're going to replace the coil, the diode, and the driver. Believe me how tempting it is now that I'm sitting here recording this video to just go ahead and peck around and try to figure out what it is and only replace one or the other. But I have done so many of these. I don't want it coming back for warranty work. I want to make sure that this job is done clean. Oh, and look, we've got a solder blob oozing out from under the coil. Is that from me and my hot air? I don't think so. Nope, no, look at that. That's actually oozing out from under the coil. So this coil has taken a lot of heat, guys. To leave that coil there would just be begging for a warranty return. So let's dig in and do this backlight rebuild. The rebuild section of this video I'm going to try to leave completely and totally unedited, as long as nothing crazy happens here. Not crazy with my repair, but microphone coming unplugged and goofy stuff like that. So for this section of the repair, I'm going to be using my blade, some hot air. We're going to heat this board up, and I'm going to start removing coating. Yeah, you know, I'm definitely going to leave this unedited because I want you to see my board popping out of the holder, the shield moving out of the way, things going wrong. I want you guys to absorb what it is that I do here to solve this. And maybe that will also help to explain why it is that I barely charge any less for this year compared to what I did last year. Now also during the course of this repair, we're going to want to be really careful over here. This is a power supply for Touch ID, and if you refloat that, then this phone is going to wind up not having Touch ID, and then that's another component that I have to address and fix, or the customer will want to drag me out and beat me up with sticks. So let's continue to clear this rubbery stuff out of here. Okay, the first component I'm going to be taking off today is the coil. Okay. Now, of course, we don't want to refloat the CPU that's right next to this mess. So I'm trying to keep my hot air off of it by itself. I'm going to go ahead and I'm going to lay one more shield on the board here that is going to help to shield my hot air off of this goofy little power supply for Touch ID, because we don't want to screw up Touch ID today. Oh, come on. Oh, man. As hard as I'm trying to be confident for my video, guys, I'm just... this has been a killer. Like, I've never been sick before to where I get dizzy. This is my first time. And I first noticed it in the shower. I almost broke my neck. Not that you guys want to hear about me showering. Oh, look, we got filter poop coming out of the filter. Alright, let's continue to warm this up. As soon as I think it's just about melted here, I'm going to start prying on it a little bit. Now, these coils normally get completely destroyed during the removal, so I'm not expecting any different here today. Plus, I don't want to heat it up too far. I want it to come up right at the earliest point possible. So, there we go. Our crazy looking coil is off of the board. Now I'm going to use my blade here and just kind of scratch this off of here. Trying not to damage the coating on the board, because we don't want to expose any ground plane here. Okay, so that is our backlight coil. Okay. Next, I'm going to start working on the driver and the diode here. Trying to keep my cover over the Touch ID components. I should probably go ahead and tape that down. That would save me a lot of headaches. Okay. Next, I'm going to be removing the backlight driver. Just trying to get a little more of this coating around the edges here so that I can tell when the balls melt. Alright. Come on, melted balls. Oh, shit, don't float the CPU. Oh. Let's move the cover over the CPU here. Alright, now I'm going to stab my blade in under here. There it is. Okay. I'm going to go ahead and put some flux on this, and I'm going to use my micro pencil to shine up and smooth out these pads, because we don't want anything rough sticking up throughout the duration of this, because if we tear off pads under here, then that just makes my repair take longer. Okay. Nice and flat so nothing can catch on them. Alright, now we're going to remove our diode. There we go. Diode is gone. Now, let's see, we can sort of unshield the CPU here for a minute, because we're not going to use a lot of heat here. Starting to get worried about balls and stuff popping out here and there. Like, what is... This came off of my driver, I'm sure. I've done so many of these, I've never actually damaged the CPU, but this one's making me nervous. Like, I got balls popping out. Okay, let's add flux. It's alright, we're men, we like round things, so pop out all the balls. There we go. Dun, dun, dun. Trying really hard to keep my microscope from shaking. I gotta do something with the stand. It's not so much the way I got it mounted to the bench as it is the stand itself. It's really not a good stand. Okay, so our next step here, I'm not sure exactly which of these three capacitors is shorted, so what I'm going to do, I'm just going to go ahead and replace all of them, because sometimes that's faster than narrowing down which one that it is. So to replace these caps, what I'm going to do, I'm going to go ahead and add some flux to this, at least get the flux on this side of them. And I'm going to try to use my iron to deliver most of the heat. I'm going to get a little bit of solder on the tip of my iron. And I'm going to start to warm this board up. And I'm just going to kind of flick these off the board. Okay, 1, 2, 3. Ba-da-da-da. Alright, let's add a little bit more flux to this. And we're going to shine up these pads. God, listen to me trying to act like I feel good. I don't know what it is about us humans that would make us feel like being sick is anything to apologize for, but it's there. I mean, shit. No! No, I'm gonna ruin my whole video. A little more flux in here. Oh. I gotta work the entire day feeling like this, guys. It's early in the morning. Okay. I'm going to use some gapped open micro tweezers here to see if I can pull some of that solder off of this. Come on, beat mofo. Okay, I'm going to say that's good. Let's go ahead and put that solder here. Alright, so all of those pads are now good for new capacitors. Okay, now I'm going to use an alcohol. I'm going to use an alcohol with some Q-tip on it. And what I'm trying to do here is make sure I don't have any underfill left under the IC. I could give a rat's ass less if we got a little bit of underfill here or there in other places, but my main concern is the IC itself. Now, it's really important for this IC to line up because you have things like backlight output and VCC main right along with I2C data lines, and if you accidentally squirt 4 volts down one of these I2C lines that's only made to handle 1.8, there could be serious and irreversible consequences. I'm not going to be trying to make sure each one of these pads is even because I feel like complete total crap. But I'm just trying to make sure that these components will sit the way that they're supposed to. So for this we're going to need a backlight driver. Oh man, I'm not prepared for this. U4020, nope, that's 6S. iPhone 6 U1502, we'll take it. That's going to be our backlight driver, right? Yeah, 1502. Okay, we're also going to need backlight coils. We're going to need backlight diodes, coils, diodes, then we need caps, right? That's going to be a 25 volt, let's see, 25 volt U0402. So for this repair, we're going to be using brand spanking new 25 volt U0402 capacitors. These are my new backlight curls, backlight diodes, and backlight drivers. Alright, so let's get this repair on the way so that I can get it done. Move on to my next job. Like I said, I might do some more recording today. We'll see. Okay, so with you back under the microscope, I'm going to go ahead, I'm going to put the capacitors in place first. And I expect them to be a little uneven because my solder is not even. And today I'm willing to totally accept that because my head's not even. How in the hell do I expect to solder anything even whenever it feels like I'm falling over the entire time that I'm doing this? I've worked sick a lot, guys, but I've never worked dizzy. This has been bad. This has not been fun at all. Alright, so I'm going to go ahead, I'm going to dump out 3 capacitors on the bench, 1, 2, and 3. And we're going to begin to sit these on the board. Now also, almost all of our solder here has been switched over to leaded, so my melting points are all much lower. I'm going to get this just started, and then I'm going to move on to the next one. Okay, 1. 2. Okay, now that those are all just started to melt, I'm going to add some flux to all of them. There we go. And I'm going to sink these right on down onto the board. Okay, there we go. There is all 3 caps replaced. We're not going to worry about anything being uneven. Those actually look pretty dang good. I've started to lower my standards as to what I'll accept and what I won't. That comes with heavy workload and not feeling top-notch. Alright, so we're going to go ahead and set the diode on the board. Okay. It's going to go just like that. I should probably use the iron to solder it on there, but I'm going to go ahead and use hot air, especially now that we're dealing with leaded solder. Okay, now we're going to sit it down in place. There we go. Now we have a diode on the board. The next thing I'm going to do is put the IC on the board. Now, since I'm a total idiot and don't remember exactly what the orientation is all the time, the IC here, if you forget which way it's turned, is going to have pin A1 out toward the backlight coil. So back under the microscope here, I'm going to dump out one of our beloved backlight drivers that most likely has leaded balls on the bottom of it, which we're going to leave. And we're going to sit this on here. I'm sorry, it's going to have lead free on it. Like some jackasses. Who puts lead free on anything? When it comes to mobile electronics and stuff that gets slammed around. I think everybody's noticed an uptick of iPhone 6 touch failures. Not 6 Plus, those are broken traces, but iPhone 6s, we're seeing more touch failures here. I think it's due to cracking balls and oxidizing pads, which I blame on lead-free solder. Alright, let's see if we can get this on the board without screwing anything up. Okay. I'm going to make sure I've got the edge of my CPU shielded here because this is going to need to be a little hotter. I'm going to make sure that I've got my stupid Touch ID driver covered up. And we're going to float this down onto the board, watching very carefully to see whenever it moves. We don't want to go any farther than we have to here, guys. There we go. That's on the board. I'm not going to nudge it because I'm lacking confidence and I don't want to nudge it too hard. Alright, let's go ahead and put some flux here where our curl goes. I'm trying to keep that hunk of stuff from coming out of my flux syringe for days. Dun, 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 dun. Okay. Now, float it right down on there. That is an installed coil. It's actually perfectly level with the other stuff. For just a minute there, I thought it was going to be too high up. Okay, so let's turn the hot air off. Switch you back over to where you can see me and what I'm doing. Now what I'm going to do here, the very next thing, I'm going to take my alcohol and toothbrush and I'm going to clean off this area of the board. I said I was going to take that sticker off the bottom, but I didn't. And that's okay. Okay. Then I'm going to use compressed air. That one didn't have shit in it. blow this off. All right. Let's look at that one more time under the microscope and see what it looks like. Okay, I really don't like how high up this coil is. It is actually up high to the point where I think it could be hit by the shield, so I am going to go ahead, I'm going to drop this coil down a little bit. Okay, so here we are, back under the microscope. I'm alright with things being a little bit crooked right now, but I don't want the backlight coil here to hold up the plate that I'm going to solder back on top of the CPU. So let's go ahead and warm this up. There we go. There we go. It's down on there nice and flat. And now I'm going to pull this solder out of here with my iron. In theory, right? Oh, you mofo. Okay, so we're going to set this down on here nice and flat. Don't make me look like an idiot. I'm trying to finish this video and not let people know just how sick I am. Alright, let's use the tweezers here. There we go. So now we don't have a bunch of extra solder blobbed out the side of that thing. And I'm going to go ahead and clean this up with some alcohol while the board is hot. What really sucks is whenever you spend all this time nitpicking and then it don't work. Alright, so we're cleaned up pretty good there. I am going to go ahead, let's see. Let's go ahead and put the shield back on it. The board's still pretty hot, so I'm going to switch you back over here to where you can see my hands. I'm going to drop the shield right back on top. And I'm going to be using hot air to put it back on. There it goes. Oops. Okay, so let's let this cool for just a second, and then we're going to see if it works. The bottom of it didn't turn out that bad. Normally I wind up with alcohol blotched all over it. Okay, so while this board cools down, I'm going to pick up all my ruckus here. Let's see, caps, diodes, coils, drivers. I don't have my parts really all that organized. I've got a drawer that's got all my ICs in it, and then I've got a drawer that's got all my other components in it. So we'll throw that away. Okay, to test this, I'm going to go ahead and I'm going to sit this back in the customer's housing. This is from alcohol on the sticky pad on the back. It puts black marks all over your workspace, which I'm very careful not to get stuff all over people's phones, and everything gets sent back really clean. So I don't like for that kind of stuff to happen. Alright, so we got the board back in their housing. I'm going to go ahead, I know it wasn't their screen that caused it. Let's see, I'm not going to use their screen. There's identifying markings on it. Let's see, I'm going to go ahead and use one of my test screens here. Assuming this one still works. Okay. Let's turn the DC power supply on the screen. There we go. Turn the supply on so that you get an accurate reading here. We're going to connect this thing up to the power supply. And then we're going to press the power button to prompt a boot. As you can see right now, we're drawing 0 amps at 4.2 volts, so we know we don't have any shorts yet. Let's see what happens when we push the button. Button pushed, 80 milliamps. Boom, we have backlight. So as you can see, I have done a lot of these iPhone 6 backlight rebuilds. It's the only reason why I felt like I could do this on video and not fall out of my chair. It's just, guys, I hope this sickness doesn't last much longer. There's a lot that I want to do, and I don't like to be down and out. So we're gonna let this thing boot, and then show you that it booted. Here we go. We're up to a passcode screen, and we have working touch. We have working image. I'm going to go ahead. The next thing I'm going to do, I can pretty well safely assume that every single other thing on this phone works, because I'm sure I didn't mess anything else up. But what I'm going to do here for this, before I put this back together, is I'm going to make sure Touch ID works. Because if Touch ID doesn't work, I'd sort of rather resolder that while the board is out of the phone. So I'm going to go ahead and boot this thing back up one last time. And I'm going to make sure we don't get an error with Touch ID. Actually, I should have checked that before we started on this repair, right? But I didn't. So, okay, let's let this boot up. And I'm going to check Touch ID. Come on. Hopefully I'm just about at the peak of this illness. I know everybody don't want to hear about me being sick, but I don't feel like I could hide it. I'm a little more shaky than usual, and my confidence has just been absolute total crap. So there has been a couple of jobs here that have just been really nasty, ugly repairs, and I've been putting them off until my confidence is a little better, because I don't want to tear anything up. Yay, we do not have a Touch ID error, and I get a buzz when I lay my finger on it. So that is a successful repair. You guys want to go ahead and put the phone back together with me? Alright, let's put the phone back together. So I'm going to go ahead. I'm going to disconnect their screen. There we go. Let's grab my screw pad here. That's going to drive me insane, because this stuff will wind up on their phone, and then I'll wind up cleaning it off their phone, or I'll find it whenever we're packing it up to ship it. Okay, I'll clean that off. And let's get this phone put back together. Being very careful where we put the screws in them. You know, it's not okay to guess. Like, it's not okay to put all these screws in a bag and then just put them back in anywhere you can fit them. Long screw damage is ugly, ugly, nasty shit. Did I just find a screw laying around? Oh dear Lord. Alright, so let's set the extra screw aside. Where the f did that come from? Seriously? There we go. Dun 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 dun. Dun 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 dun. Okay. Oh, I see where that screw came from. My little bracket's not laying there on the screw pad, so I was a little confused. That's a screw from this goofy looking thing here. So we'll go ahead and put that back on. We're almost done with this repair. It's not the right screw. I might have gotten those two confused. That could be. It's also important to know when you can get away with substituting a screw. Like, I know I'm not drilling this into the circuit board. Oh yeah, that's much better. There we go. There we go. Alright, let's plug the antenna cable back in. Which I like to do under the microscope. There we go. Now we're going to put the customer's screen back on it and finish this full reassembly. And then we will have an iPhone 6 backlight rebuild start to finish with nothing left out. All my struggles and balls and dizziness and lack of confidence. And confidence is king with micro soldering, guys. And when your confidence starts to suffer, it's very difficult to keep a level head. And I think if you're not feeling up to a repair, it's probably best to come back to it. Repairs that you've done repeatedly and are entirely routine, those aren't too bad to get through, but if you're feeling less than confident about something that could be risky, I think it's just best to come back to it. There we go. I think my camera's auto exposure is going to cover up the job number on this one. But just in case it don't, I'm going to go ahead and say job ID 5169, your phone is going to be fine. This came in, let's see, this one hasn't been here this long. This is what I consider to be a routine repair. You'll notice on our website that I quote different turnaround times for routine versus non-routine. This one falls into the category of routine, and I'm actually getting ready to lower my turnaround time for routine repairs. Alright, so we're going to put the SIM card back in it. Hey, they are Cricket customers. I like Cricket. Okay, there we go. We've got the phone completely reassembled. I'm going to push the power button. Oh wait, you know what? This was full short. Full short means pressing the power button is going to do nothing. Where's my chargers at? Alright. What in the heck kind of repair shop has to go track down a lightning cable whenever it's time to test something? Seriously? Thank my children for that. All right, we're going to connect power to this thing, and we get charging icon. Okay, so we're not going to sit through all this. I'm pretty confident that this one's going to be fine. Guys, I do thank you all for watching my videos. There's a lot of you that have been with me since early on, and I can't tell you how grateful I am that you guys are still there commenting, and it really means a lot to me. So without getting too emotional here, head cold, it's getting to me. I'm going to go ahead and call an end to this video, and I'm going to move on to my next repair. I've got a really nasty one here that I might record a clip of here in just a little while, but we'll see. That's it for now, guys. Thanks for watching, and I will see you next time. Have a good day.